just Ladyada.
Hey everybody, and welcome to my desk. As you can see, I've been re-pinkified. A lot of hardware going on my desk today. It's a long weekend for some folks, so if so, I hope you have a good long weekend. All right, let's go straight to the computer, and I'll talk about some of these displays. So, I've got much more TFT displays that work with the Qualia board. The Qualia board is well, it was in stock. Yeah, it's still in stock. So you can pick some up. And we've got, bar displays, square displays. I think we've shown on this show as I've been like trying to get them working. This week, in addition, Melissa wrote up a guide. She's like mayor of Displaytown, mayoress, I don't know, queen of Displaytown. So she's done a lot of the display work for e-inks and TFTs, and so it made sense for her to also write this guide. We have CircuitPython support, and she's got quick start details. Hold on, let me see if I can get one moment. CircuitPython display setup. So she's got basically all the init codes converted, and so all these displays, you need the exact right init code to make them work, the timings, and then a ready to go example in CircuitPython that will have the REPL show up. You can see here that REPL is appearing. And one of the things that, as I've been playing with these displays, they're definitely, and you can see more, these are draft pages. Getting these displays working, it's definitely one of those it doesn't work until it's 100% perfect. And I think a lot of people are, I've noticed, especially with a similar board, the Matrix portal, it's is the display broken or is the board broken? And it's there's a lot of this back and forth. We don't know which half might not be working. And so what I decided to do is create this ready to go demo, which I think we chatted about on a previous Desk of Ladyada. I used ChatGPT to write this cool color wheel that is kind of like the NeoPixel rainbow demo, but for displays. And this is what it looks like. It makes this, it's circular here, but basically, 360-degree hue and saturation circle, or sorry, red, green, blue circle. And so to get people going really fast, I decided what I was going to do is, I basically recompiled this code for each display. If you look at let me actually do the preview. Hold on. Yeah, okay, here. So, oh, interesting. This did not initialize the latest code. Okay, hold on. So here is, sorry, might not have committed. So what I did is, for each display, I have this commented out section for it's okay, do you have the 2.8 square, round, bar display? I have the init code ready to go, and you just uncomment it, and it's the same display code, maybe, but for different resolutions. And then I also updated the color wheel demo. The original demo was hard-coded, which this should be. So you see it's hard-coded to 240 by 240. And I was like, oh, I have to update this to be for any size because I have these bar displays and I have square and I have different resolutions. And I was about to adjust it. And then I was like, oh, wait, I'll just go back and ask ChatGPT to update it. So I just said, hey, I'm back. I like to introduce myself and say, hey, I'm back. Hey, remember we wrote this code, a couple weeks ago. And so just making sure I had that context. And then I was like, great, can you just update it to be width and height dependent, not hard-coded 240 by 240? And actually did all of it. And it's always kind of, you're not sure if it's at oh, divided by 2 or is it subtract from 1, it's kind of hard to remember, especially for the bar display, right? With the width and the height are not the same. I didn't want to have them swapped. And so I, having done that, I updated the code here to what ChatGPT 4 suggested. And then I built these UF2s. So if we go to the overhead, I can show this is our, it's so big, it takes up the entire screen. So this is our ginormous 4-inch display. And you can see it's much more vibrant in person, of course, but this rainbow display on here. I will say it does flicker a little bit, and I think that's because I'm still in Arduino using IDF, like I think 4.4. In CircuitPython, we now use IDF5, thanks to Scott. If you checked out his videos, he did an update to implement ESP IDF 5.1 in CircuitPython. And one of the things that it improved was the RGB TTL display support is much more stable, greatly improved. But what's nice is that, I can double click this reset button and it goes into bootloader mode. And of course, this gets all weirded out. Actually, I'll show you something interesting. If you, so it's kind of a neat effect. Let me just reset this. So this is just, the rainbow demo. If you, oh, actually, it's not gonna work. But if you put in, let's say this is a 3.4 inch. So this isn't gonna work at all because this is a different chipset. This is the SS 7701. But let me put it into bootloader mode, and then I'll just drag and drop this onto here. Hold on. Oh, no. One thing I've noticed is that the ESP32. Uh-oh. Oh no, my hub is broken. Can I reset my hub? Yeah, let's see why not. Sorry, live demos. Okay, that broke. That's okay. I got another one. Weird. Oh no, my hub is definitely not working. Okay, well, forget it. Pretend that I had the demo show up on all of these. Give it one more try. My hub is like, by the way, there's nothing like doing hardware design on Windows to make your operating system USB core like totally freak out. Okay, it seems like it recovered somewhat. Let's try. I'll try uploading it again. Sometimes when you threaten the demo and say like, fine, I'm giving up on the demo's like, oh, I'm gonna get it together. Let's see, and then, oh, hit reset too fast. Sorry. There you go. So now, I just installed the version for this square display. So that's kind of nice. And then I was going to show is that if you swap out the display without changing the code, sometimes you get like a cool, like glitchy effect. Or not. You know what? It's okay. I'm going to move on. Okay. All right. I'm not having good demo luck. That's okay. All right, so let's move on to another demo, which might work. So this is another piece of hardware I'm working on. So this is the USB Host Featherwing. I don't know if I chatted about this on the show or in, I don't think I brought this onto Desk of Ladyada, but this allows allows implementing a USB host interface. It's a USB Type A connection. With any microcontroller, so it doesn't have to be an RP2040, has a little boost converter, USB Type A connection, and then if we go to the computer, 1 second, I am having a hub day. Oh boy, I don't want to connect directly, but sorry. Let's try restarting again. Let me disconnect some items too. Lots of USB stuff happening. Okay, let me see if that. I'll move on to other stuff. Nope. Okay. Man, my cameras are not working today. Well, despite it not working, let me show the example code. So in Tina USB, you'll just have to believe me that I had it working. under dual role, you can actually have it connected with the USB host shield when it works. And it will appear as USB host. You can plug in a USB serial cable like this one, and it'll actually like appear as like a a software serial or like a software implemented serial called USB serial host, and you can read and write to it. So you have something like a GPS, or I was actually having it connected up to this ESP32. I'm gonna give it one more attempt. Wow, it's just not working, huh? Okay. No. I'm sorry. Definitely worked before. You can connect it directly to the USB host and read to it. So for example, I had this wired up to a GPS. You have like a USB GPS, or you have like a ESP32 board that has built-in serial. My hub is now like randomly turning on and off. And you can read and write from it. Maybe I'll have the demo ready for next week. I guess, might have to probably reboot my computer or something. But it happens. All right, so USB host Featherwing, gonna work on that. And, I think that's probably gonna be coming out in like maybe like a month or so, maybe a month or two, and then we'll add CircuitPython support. But right now it does have Arduino support. If you have like a USB host shield, and a lot of people do try this out. It should work because it's the same MAX3421 chip. All right, well, USB is cursed, but that's okay. Let's go into the great search.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Native Fruit. Thank you so much, DigiKey. Every single Ladyada uses our power of engineering to help you, yes, you find things on digikey.com. Ladyada, what are you searching for this week?
Okay, so this is actually, sometimes I just look online and I'm like, hey, what? I read the blogs and stuff, and I saw this post, it's just a couple weeks ago, from OH8 Hubs. And they had this post, about they were using one of those like Qi chargers or like a mag charger with their phone, and it's like an Apple device. And they were doing VHF work, and they actually were noticing that there was some radio interference on VHF. And they showed, oh, hey, if you ever have a device, and like these are, the whole thing is an EMI machine, like it manufactures EMI. And so maybe it was not within the spec, or maybe it was, I don't know. But they said, oh, they really reduced it by putting on a clamp on ferrite bead. And I was like, oh yeah, those are really useful. So let's go to the overhead, because I happen to have a cable that has these built in. So this is what you normally see. This is a USB cable. Although you don't see it as much anymore, although I don't know why, but maybe like USB hosts or USB devices are better at reducing EMI in different ways. Maybe they have like inline resistors or like lower drive strength. But this cable, USB to mini, has a ferrite bead implemented or installed on both ends, which is like pretty serious. Maybe it was required for the product that this shipped with, who knows. But these are molded in, and if you can get molded in, great. But as you saw, there's some cases where you have a device post installation where you want a clamp on ferrite bead. And you would use test equipment to determine whether or not it's passing the EMI floor that you're looking for. They're not like specified for like, oh, this will reduce EMI by this much. Like they're specified by the width and thickness, inner diameter, outer diameter material. But there's no like magic number like, oh, use this size for this frequency to reduce it this much. It does depend a lot about the product that you're using, the cable length, the drive strength, the amount of current draw, et cetera, et cetera. So let's find, and then they were like, they did go through the data sheet and check it out. I think they bought it from a British company, but turns out DigiKey stocks this stuff as well. So let's go to the computer and I'll show you. You can get ferrites. So in general, people use ferrites as chips, and we use this in a lot of our designs, like an inline ferrite between your digital and analog power. It has some resistance at high frequencies, and the resistance increases. So like at high frequencies, the resistance is higher. At low frequencies, the resistance is basically zero. And so if you set it up like as an RC filter, it kind of blocks that high frequency noise from coming through. There's also cores if you want to, of course, make your own inductors. I don't know how many people do that these days. But what we want are cable ferrites. And you saw even the icon was indicative. So a lot of these come, like for the cable we showed, where you would put it on and then mold over it. This one's kind of cool. It has like 2 apertures. So you can have, 2 areas. There's also flat cables, for ribbons. I think, I don't want to pull out my Apple II floppy drive, but I remember it had like I think it had a ribbon cable and a ferrite that the ribbon went through. But we want one that's clamp on. So first off, let's go only for active, because we don't want to get something that isn't available right now. And for design, there's clamp, clip together, and hinge. And I think like we should just do all of those. I'll also get the dash just in case we need it. And then let's also only look for in stock. And that gives us a lot of options, like 270 options. All those look pretty good. So this is what they look like, right? And you put the cable through. You can, they are specified for the resistance at, high frequency, usually like 30 megahertz or 100 megahertz. The higher the ohmage, the more resistant it's going to be at those high frequencies. But, it also will, you might have to pay more, but they might be bigger. So you'll have to decide what size you want. Let's see what else we want. I think we want only the round type. And so let's do that. And then the material is going to affect the, that response curve, as you saw. What I did is I just actually looked like what is like the most popular one. And there were, quite a few options. It looks like Ferrite, which is like ferrite, but like Ferrite, just, it's a good name. The one, a lot of these are good. I think I found this one, they had 43,000 stock, nice and small. What I liked is that, it had a pretty big inner diameter, a 1/4 inch wide cable can fit through it. So this would do a job very well. And of course it clips on and off. Once you've clipped it on, you might want to use some tape or something to keep it. You don't want it to slide up and down. You want it to be like, near the connector. And then of course in the data sheet, this is clearly layered. This is their thing. They will give you, what is the resistance at the frequency, the impedance at the frequency. So depending on the frequency that you want to block, you'll want to get different materials, LF, 28, HF, these are different materials. If you want to block out gigahertz, 1 gigahertz, HF is going to be like your bag. But if you're like, no, I need to block everything over, 5 to 10 megahertz or something, you want LF. So choose the different material. It looks like they've got some good ideas. This is kind of a nice data sheet. And then, of course, they will give you the specs for all of the different sizes, including there's CAD files and dimensional data. So it looks like they kind of have everything covered. I don't know if this person was, I think they kind of just bought a couple different beads, and they do have bead kits, I think, at DigiKey. And they just clip on the one until, I remember talking to an engineer and they said to pass FCC, you just try different ferrite clamps until basically it passes. So, and then that's the one that you ship your product with. So this is my pick, but there are many, many, many options. So don't, this is one of a wide variety of hinged ferrite cores.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
All right, and that is our show for tonight.
Yes. I'll get my live demos working for next week or maybe
Yeah,
for
well,
Wednesday.
it's
You know
okay.
what? It's like, it's cool. It
Yeah.
happens. But you guys get the idea. Maybe we'll shoot some video later
Yep.
this week too.
We'll see everybody during the week. Thanks so much for joining us. See you next week.
Bye, everybody.